Right, okay. Hello, everyone. Today we're going to be talking about series and parallel circuits. So, if on your screen you see a pause symbol in the corner like this, then it means pause. I'll also tell you when to pause the video as well. Okay, so we're just going to start off. Can you remember the circuit symbols for a cell, a battery, and a bulb? So give yourself a minute to get those written down. If you pause the video now. Okay, so what you should have had is a cell is this longer line here with a slightly shorter line next to it. A battery is made up of multiple cells together. So you can see here there are two cells together, so it's a battery. And then a bulb or a lamp is represented by a circle with a cross through the middle. So when we talk about electricity, it's really, really difficult to be able to explain how it works, okay? Because you can't see it, you can only measure its effects. So we use things, models, okay, to try and show how it works. So if we have a look at this model here, the water in the circuit, so represents the charge. So the water, you can see it's in all parts of the circuit. It's there all the time. And this represents the charge that's found in an electrical circuit, so in conductors such as wires. Then when we turn on the pump, so the pump is a source of energy. So that could be a battery or a source of electricity. This causes the water to start moving. Okay, so remember the water represents charge. When it starts moving, that flow of water represents the flow of current. Okay, so current is what flows around a circuit. Okay, it's what moves around. And then you can see here, the movement of the water is causing this wheel to spin. So the spinning wheel represents a component within a circuit. So a component is something like a light bulb. So when the current starts flowing, the light bulb would light up just as the water starts flowing here, causing the wheel to spin. So the height difference, you can see here, the water is increasing after the pump, and it's increasing in height there, and it's decreasing in height here. So when it increases in height, remember it gains potential energy. When it flows downwards, it loses that energy, and it's causing that the wheel to spin. So that energy has been transferred into kinetic energy in the movement of the wheel. Okay, so this is just saying the difference in the energy of the water before the wheel spins as after the wheel spins is the wheel's potential difference. So this is also known as voltage, and it's basically telling you how much energy that wheel is using. So in an electric circuit, say we had a bulb, for example, you would measure the amount of energy going in before the bulb, the amount of energy going in just after the bulb, and then the difference is how much energy that bulb has used. So, series circuit. So in a series circuit, there's only one path the current can take. So current always wants to go back to the battery. So you can see here, the current starts here, it moves around, it goes through both components because there's only one route for the current to take, and it makes its way back to the battery. If, for example, this bulb breaks, then there's a break in the circuit, the electricity can't go back to where it started, so it won't flow at all. So the other bulb will go out, okay? So this first bulb goes out, which breaks the circuit, which means the second bulb also goes out. In parallel circuits, it's slightly different. So you can see here, here's the bulb, the current starts flowing. Some of the current can go down this path here, and some of the current can go down this second path here. So parallel circuit is when there's two paths for the current to take. So if, for example, this bulb goes out, the current can flow from the battery. It can still get back to the battery because it can flow through the second route, okay? There's still a complete circuit in the second route, so the other bulb will stay on. So which statement is false? So if you want to pause the video, have a read through, decide which one. So if you pause it now and have a read through. Okay, so the false statement here is in a series circuit, the amount of current flowing changes, okay? Because the current has to flow, only has one route to flow through, it stays the same in a series circuit, okay? Let's read through the other statements and just show how they're right. So in a series circuit, current is the same at each point. Well, if the current flowing only has one route, it's going to be the same at each point. Statement B, in a parallel circuit, current splits between the paths. Well, if we have a look back at this slide here, you can see if the current is flowing here, then half is going to go down this route, half is going to go down this route, okay? So statement B is true. And then statement D, in a parallel circuit, there is more than one path for the current to take. Well, because the current splits, that tells you that there's more than one path for it to take. So if we have a look back at this slide, it can either take this path or this path. There's two different options. So when we talk about current flowing, okay, it's basically all of these atoms flowing along the wire. Okay, so current, we said, was the flow of charge. The current is flowing along the wire. So we've talked about current in series and parallel circuits, but what about voltage? So we've said that voltage is the amount of energy a component uses. So this is a series circuit. You can see the batteries here. There's only one route for the electricity to take. It's a series circuit. So in a series circuit, there's only one path. Therefore, the energy in the circuit has to be shared between both components. So if we have a look here, if you normally look at batteries, it will have a voltage on it. So this battery, for example, has 8 volts. So this component here is going to take half of the voltage. Because there's two components, it has to be split. Okay, so this one's going to take 4 volts, this one's going to take 4 volts. However, in a parallel circuit, so we've said that there are two paths. So you can see here, there's one path here, and there's another path here. So in a parallel circuit, there are two different paths, okay? Therefore, when the energy is leaving, 8 volts will go to this component, and 8 volts will go to this component. So the energy on each path will be the same as the energy from the battery. It's only if that energy, the voltage, needs to be shared between two components on the same path. So we're going to read through some statements here. What I want you to do is decide whether they're series and parallel. Then at the end, we'll look at the completed table and see how many you got right. So current is the same in all parts of the circuit. So you should have put that in series. Voltage is shared between components. Okay, well, that's when components are in series. If one bulb breaks, all of the other bulbs go out. Well, that's when there's only one path for the current to take. So that's also going to be series. And bulb brightness decreases as more bulbs are added. Remember, in a series circuit, the voltage has to be shared between the components. So if you've got two bulbs in series with each other, the voltage has to be shared between them. So that's also going to be series. So bulb brightness is constant as more bulbs are added. Well, in a parallel circuit, as you add in extra paths for it to take, the energy stays the same. Voltage is the same for each component. Current splits are branches and so varies in the circuit. Well, it's more than one route in a parallel circuit, so it needs to split. And if one bulb breaks, the other bulbs remain. That's because there's another route for that current to take. Okay. So you can see the pause symbol in the corner again here. So what you're going to do is read through the statements and then decide whether it refers to a series circuit or to a parallel circuit. So if you just get a piece of paper and then A to H, say whether it's series or parallel. So if you pause it now, okay, so you should have put all the statements down now and said whether you think they're series or parallel. Let's have a look if you were right. So all of the current flows through all of the components. Well, that's because there's only one route to take, so it must be a series circuit. If one bulb breaks, then the others go off. So the bulb breaking is breaking the circuit, which means that there's obviously not another path for it to take, which tells you again that it's a series circuit. The bulbs do not become dimmer if you add more of them. Well, if the brightness of the bulb isn't changing, then that tells you that the energy isn't being shared. So that must be a parallel circuit. All of the bulbs are either on or off together. So that tells you that if one goes off, then the others all go off with it. So that is what happens in a series circuit. Each bulb can be switched on or off separately. So that's the opposite of that previous statement. So that's a parallel circuit. The current is the same everywhere in the circuit. Well, if the current is the same everywhere, that tells you that there's only one route for the current to take. So it's a series circuit. If you add more bulbs to the circuit, they all become dimmer. Well, that tells you that the energy is being shared between the bulbs, so it's a series circuit. And if one bulb breaks, bulbs in other branches stay on. So there it's talking about other branches. When there's more than one branch, more than one route for the electricity to take, it's a parallel circuit. So we're going to go back to the starter activity. You're going to do a really quick recap. So you can see the pause symbol in the corner again there. So after I've read these out, you're going to pause it, answer the questions. We'll then go through them and then we'll get on to the written phase. So what are the circuit symbols for a battery, a cell and a bulb? What is the difference between a series and a parallel circuit? So if you pause the video now. Okay, so what you should have had is that these are the symbols for a cell, a battery, and a bulb or a lamp. And then what's the difference between a series and a parallel circuit? So in a series circuit, there's only one route to take, whereas in a parallel circuit, there's more than one route. Okay, so that's the main distinction between series and parallel circuits. So the written phase, again, you can see the pause button. So in lessons, we usually spend about 15 minutes on the written phase, so you can leave this paused as long as you need. So the state task is draw a series circuit with a cell and two bulbs, and a parallel circuit with two bulbs and a cell. Explain what happens to the current in a series circuit and in a parallel circuit. So you can just write a sentence about what happens to current in a series circuit and a parallel circuit. Detailed explanation. Explain what happens to voltage in a series and parallel circuit. Explain which bulbs would shine brighter, two bulbs in series or in parallel. And then for combined, draw a parallel circuit with one bulb on the first branch and two on the second and a 6-volt cell. What is the voltage across each bulb? So you can pause this now, spend time answering these questions. If you need any help, you can rewind the video. The answers are all there previously. Obviously, there's no one that you can ask, so you can go back and look at the video. Okay, so answers. Draw a series circuit with a cell and two bulbs, and a parallel circuit with two bulbs and a cell. So here is your series circuit. It's got a cell and two bulbs. So your drawing should look something like that. And then this is a parallel circuit with a cell and two bulbs. So you've got your cell here, a bulb on one branch and a bulb on the second branch. Okay, so your circuits should look like this. So explain what happens to the current in a series circuit and in a parallel circuit. So the current is the same at all points of a series circuit. Remember, there's only one path for the current to take, so it stays the same. In a parallel circuit, the current splits at junctions and flows across different branches. So if we go back to this slide here, some of the current will go down this first route, some of it will go down this next route. So explain what happens to voltage in a series and parallel circuit. Explain which bulbs would shine brighter, 2 bulbs in series or parallel. So in series, the voltage is shared between components. If you've used the word components, then that's really good. Well done. And in a parallel circuit, there's the same voltage across each branch, okay? So if you've got a bulb in one branch and a bulb in the other, then they've both got the same voltage as the battery. When it says which would shine brighter, well, because the energy is being shared in a series circuit, then the bulbs in a parallel circuit will be brighter because they're not having to share that energy. And then for combined, draw a parallel circuit with 1 bulb on the first branch and 2 on the second and a 6-volt cell. So the first bulb should have 6 volts. And then each of the other bulbs should have 3 volts. So your drawing should look like this. So you've got your 6-volt cell here. Across your first bulb, remember, 6 volts of energy goes down this route. There's only 1 bulb for to use that energy. So that bulb is going to be 6 volts. On this next route, okay, there are 2 different components to share that energy. So that voltage has to be split in the same way as if you had a series circuit. When it's going down this route, that voltage has to be split. So each one should have 3 volts of energy across it. Okay, and I think it's still really important. I know this is a revision lesson, but I still think it's still really important for you to write this sentence. So today you've achieved, and then you say what you've achieved. So remember, it's the word, not the color, because you're able to, and your reason is here. So this is really important. So even distance learning, you can still say what you've managed to achieve today. Okay. So well done. I'm sure you've all done brilliantly, and I'm sure we'll be uploading more videos soon. Hope you all have a wonderful Easter.